guys, we're gonna make a hammer.
All right. So I'm trying to elevate my mood. So I graded everybody's tests.
Oh, no.
And how would you like?
You look very cute, Miss Miller.
Thank you. Thank you.
How did I do?
Yeah. Test was interesting. Although my TA last period reminded me that there was one test last year that everybody did not do well on, and she said she thought it was the same one. So I'm hoping that's the case. We'll find out. No. Not all of you. No. Okay, here we go. So okay, so here's the good news. We are moving into something very easy.
Okay.
Okay, so so you all see up here, I heard some of us chattering about the whole square root -1 heart math thing. You all are about to find out what that means. Okay. Okay. So, here we go. Everybody shout it out when you know what number I'm about to put up here, what it is equivalent to, okay?
6.
Okay, let's keep going.
5. 4.
7.
Finally got the yellow. 13.
Everybody really... Okay, I will satisfy the craving that's out there. Are you ready? Let's see.
13. I said it first.
Now, ready? Okay, here's where it gets awesome.
-4.
No, 4. With a negative on the second line.
Okay, so a lot of people are looking confused. So
Equals I.
it equals I, just I by itself.
I4.
I4, like this?
Sounds like bingo. Sounds like a freeway. Yes.
Okay, here we go. You guys are very close. Very, very close. It's not I4.
I know.
4I. Very good. Okay, so here's how this works. Okay, this is working. It's getting me into a better mood. Okay, ready? Okay, shh. Let's not put me back down there. Okay, so here's how this works. Up until now, we have not had the ability to take square roots of negative numbers, correct? Because, okay, you guys tell me, why is the square root of 16 4? Because, okay, positive. Positive times a positive gives you a positive. Squaring something is multiplying it by itself. There's no way you can get that if you have a negative number here. The only way to get a negative number by multiplication is by multiplying a positive with a negative. So up until now, this has not existed. But here's how this works. So we can actually break up the square root of -16 into the square root of -1 and the square root of 16. Okay? The square root of -1 has a value of I. I represents the imaginary number. So I equals or is equivalent to the square root of -1. And then the square root of 16 is 4. So this is 4I. Okay? So let's write that over here. You want to remember this. I is it's the square root of a negative, but we can't just have a negative. So we attach the most basic multiplicative number to it, which is 1. Okay, so now, what about I squared? If I equals the square root of -1, if I square both sides of this, then I squared is equal to what? What squared and square root do what? They cancel. So I squared equals -1. Okay, you need to remember these. Okay, those, as long as you remember those, this unit is going to be really, really easy for you. If you don't, then we're going to have another test like we just had. Okay, here's hoping.
Was it that bad? Were there any A's?
There were a few A's.
We didn't get the mean or the motive. You didn't give us any.
I haven't given that to you yet because I didn't want to calculate it. I didn't want to get more depressed. Okay, here we go. Write in I form. So actually, if you notice, if you go back to any previous math textbooks, so a lot of the time, so X is a really common letter that's used for variables, Y, A, B, C. But if you look, I has never been assigned to anything because it actually has a numerical value assigned to it. Same thing with E, which you'll learn about later on. Okay, write in I form. Okay, so here we go. The square root of -9. So, who can tell me, raise your hand if you can tell me what the square root of -9 equals, Akashni. That's good, 3i. Everybody give it up for Akashni. Okay, negative square root of -1/16. All right, so here we go. You can basically ignore that negative that's outside of the thing. Jared?
Wouldn't it be 1/4 I?
Good, and keep the negative in front. So I, 4, top and bottom, and then the negative in front. Excellent. Everybody give it up for Jared. Or if you wanted to write it as -1/4 I, that means the same thing. Pretty easy, right? Yes? No.
It's gonna get hard, I know it is.
Okay, this is where it gets complicated. Okay. Well, I know that's how you all think. So this is about as complicated as this gets. 4i minus 1i is
3i?
3i. Good. Just like variables, like combining like terms. -2i plus 2i. 0.
0 eyes.
3i plus 4i.
7.
Can't write fast enough. Okay, shh. -4 plus 10i plus -2 plus 3i. So this is literally, it's literally combining like terms. So -4 plus 10i and -2 plus 3i. So in this case, you treat it like a variable, but we now know that this has a numerical value assigned to it. Jared?
-6 plus 13.
Cool, give it up for Jared. All right, here we go. Let's keep going. Multiply or divide. Yeah, these are quick. This is one of my favorite units because it's really easy. Okay, rationalize. Whoops, let's write this in. Rationalize the denominator when necessary. You can't have a radical in the denominator. Okay, here we go. 7i times -3i. So again, you still treat these like variables, but now we know that. So if it was 7x times 3x, it would be what? All right, somebody tell me what they think this is.
-21i.
What is it?
-21i.
It's just I. -21i. What's I times I?
I
I squared. But I squared has a value of what? -1. So it's -21 times -1, which is +21.
Oh, God.
What's wrong?
It was awful.
It was magic.
Okay, shh. Everybody zip it. Is there a question on that? That's why I said you have to remember that I squared is -1, and I by itself equals the square root of -1. You have to memorize that. But that shouldn't be too hard to memorize because we can't take square roots of negatives unless you have an I value associated with it. Okay, here we go. 2 root -5 times root -45. Okay. We want to get these negatives out of the radicals first. Okay? So we can rewrite this as -square root of 1 times +5, sorry, and -1 +45. So when I do that, what do I replace the square root of -1 with again? I. So it's 2i root 5 times I root 45. Okay, now what? Yeah, you can, so good. You can multiply it all together and then simplify, or you can simplify first and then multiply. So if I'm looking at this, I just don't really want to do 45 times 5 in my head because I don't really feel like it right now, so we're not going to do it that way. So here we go. 45 is what? Times what? 9 times 5, right? Square root of 9 is? So 3I root 5. And now if we go through and multiply these, we get, somebody tell me what we get. Multiply everything outside of the radicals together and everything underneath the radicals together. Lydia.
Okay, the 6I, but then can you multiply it by 5 because the square root of 5 times square root of 5 is 25.
Good.
Square root of 25, so it's
Okay, good. So
30, yeah.
is it just I? What's I times I again?
Oh, squared.
I squared. And then the square root of 5 times the square root of 5 is the square root of 25, which is what? 5. Okay, so we have, what is I squared equivalent to again? Negative 1 times 5. What does that all come out to? Good. Questions? We are almost done with our lesson for the day. I need more paper. Did I hear that Underhill wants more problems? Okay, here we go. All right, so we can do one more of these and then we can be almost done. 3I, nope, let's do this. 4 divided by the square root of negative 32. So 4 divided by the square root of negative 32, that is the same thing as 4 over the square root of negative 32. Okay, so we want to, again, simplify as much as we possibly can. So we can write this as the square root of negative 1, square root of 32. Square root of negative 1 is what again? I. So it's I root 32. Can anybody think of how we, oops, sorry about that, how we can break up 32 so that we have a perfect square times something else? So 32 is something times something, of which one of those numbers is a perfect square? Kendra? 8 and 4? Does anyone think of a little higher? 16 and 2, good. So I times root 16 times root 2. What is the square root of 16? 4. So it's 4I root 2. Okay, now what? Whoops. Now what? Okay, we can cancel out the 4s. And then we're left with a 1 on top. I feel like we're going really fast. Are you guys hanging in there okay? Are we going too slow?
Oh, no, you can go faster.
Okay, so 1 over I root 2 is where we are. Now, we can't have any radicals in the denominator. So how do we get rid of the radicals that are in the denominator? And yes, I said radicals plural because there are 2 of them there. Jade.
Multiply by the radical.
Okay, so what am I multiplying by? Okay, good. So we multiply by I root 2 on the top and the bottom. Good. Okay, now you have to remember that I represents a square root. Okay, so you can't have any i's in the denominator either. So you don't only want to look at the obvious radical sign there. You want to get rid of the i's as well. Yeah, Lydia?
So this is rationalizing.
Yes. Rationalizing the denominator is taking the radicals out of the denominator. Okay, so on the top, what do we have? I root 2. On the bottom, we have I squared root 4, which ultimately reduces to what? Negative 1 times 2. So we end up with I root 2 over negative 2 is our answer. It's a good answer. Yes, it is. Okay, questions? Okay, last problem. Okay, so here is how we want to do it. Anytime we have an I with some exponent attached to it, we want to get it down to its simplest form. All that means is we want to write it in terms of just an I by itself or no i's at all. So that's why I gave you all the whole I squared equals negative 1 thing. So how many people agree that I can rewrite I to the 5th as I to the 4th times I? Yeah? Okay. And I to the 4th is the same thing as I squared times I squared. Right? So the whole point here is we don't want to have an exponent of 5. Okay, that's not a fully simplified imaginary number. We want to get back down to just I or 1 in some way. So what is I squared again? What is that equivalent to? So negative 1, we have 2 negative 1s times an I, comes out to what? I. 1 times I, which is just I. Let's do one more and then we're done. How about I to the 12th? So how many people agree that I can write I to the 12th as I squared to the 6th power? So this is where we want to know our exponent properties really well. Is that true?
Yes.
And I squared is what again? Negative 1. So what does that, when I multiply that out, negative 1 by itself 6 times, do I end up with negative 1 or positive 1? How do I know that it's positive?
The exponent's even.
The exponent is even. Excellent. So if it ended up being negative 1 to the 5th, it would be what?
-1.
Negative 1. Cool. Questions?
No.
Yes, Lydia. What's the point of what?
What is the point of writing out I to the 12th?
Okay, because they're asking us to evaluate them. So that's what we're doing, is evaluating them in terms of I or 1. That's all. We're just getting, so it's just getting practice breaking it down from larger exponents to smaller ones or no exponents. Okay? Other questions?
Why do you have 3 books? That's not fair.
Okay, so page 316, numbers 5 through 75, multiples of 5. Sounds like a lot, but you see how easy these are. Okay, everybody go ahead and get going.
Oh, multiples.